In this video, we're going to look at division of complex numbers. So how do we divide one complex number by another? Now, it's a little trickier to do than the addition, subtraction, and multiplication of complex numbers that we looked at in the previous videos, but it is possible. So whenever we're doing anything like this, addition, multiplication, division, the real question is, how do we write the thing as a plus bi in the standard form for a complex number? So all complex numbers are numbers in that form. So if we can divide one by another, we should be able to write the answer in that form. So we could easily just write a plus bi over c plus di, for instance. We're going to see that, but then how do we convert that to the standard form? So that's really the question for this video. So we need to start by making an observation. So it involves the following definition. So if z equals a plus bi, so z is a complex number, then its complex conjugate is denoted z bar, so z with a line over the top, and it equals a minus bi. So for any complex number z, we can take its complex conjugate, and that is simply the number where we change the sign of the imaginary part. So if a is in the form a plus bi, and every complex number can be written in this form, then if we change b to minus b and take a minus bi, this is called the complex conjugate of z, and we denote it z bar. So z with a bar over the top. Why are we defining this? Why is this important? Well, let's just have a look at what happens when we times z by z bar. So we times a complex number by its complex conjugate. Well, we get a plus bi, that's z, times a minus bi, which is z bar. And we know how to do multiplication of complex numbers because we saw it in the previous video. So this becomes a squared. We're just going to times everything by everything in these two brackets. So a times a is a squared minus abi. So that's the a times the minus bi plus abi. That's the a in the second bracket times the bi in the first. And finally, plus b squared. Why is it plus b squared? This might look a bit strange. Well, we get bi times minus bi. That's b times minus b is minus b squared, and then times I, which is I squared, which is minus 1. So we get minus b squared times by minus 1, which is just plus b squared. So you can try that yourself if you don't believe me. Write down bi times minus bi. Remember, the I squared is going to become minus 1. Cancel the minus signs, you get b times b, so just b squared. Now, what we know is that minus abi plus abi cancel out. So these two terms cancel. One's the negative of the other. So we just get a squared plus b squared. So what's the point of this? The point is that we had two complex numbers that had imaginary parts, and when we multiplied them together, we ended up with just a real number. So there's no imaginary part. The imaginary parts cancelled out. It disappeared, and we just got a squared plus b squared. A and b are some real numbers, so this is just some real number. So this is going to be important when we're doing division. So let's look at an example. So we can calculate a plus bi divided by c plus di. So this example is just a general example. We have two general complex numbers, a plus bi divided by c plus di. We know we can calculate this, but that means we must be able to write it in the standard form of a complex number. So if we write it as a fraction, a plus bi divided by c plus di, the question is, how do we convert this to something of the form f plus gi? So I'm just using f and g because I haven't used them yet. I don't want to use e because e is already a number, so it might get confusing. So f and g I'm just using to represent the real part and the imaginary part of this number that I obtained by dividing a plus bi by c plus di. So I'm saying I think I can write it in this form. F and g are some real numbers, but how do I find them? Because it's not currently in that form, written as a fraction. So how do I do this? How do I get from a plus bi over c plus di to f plus gi? Well, let's have a look. So we take a plus bi over c plus di, and what we do is we multiply. So we say that this equals a plus bi over c plus di times by c minus di over c minus di. So this is the most important step. Once you remember to do this, as long as you can then work everything out, you can get the answer. But why are we doing this? Well, c minus di divided by c minus di, it's just something divided by itself, so it's equal to 1. So we haven't changed the value of this expression. So it's okay to do this, these two things are equal. But why are we doing specifically c minus di? Well, this is the complex conjugate of the number on the bottom, the denominator. And if we therefore times the denominator by its complex conjugate, we'll cancel out the imaginary parts and we'll just get something that's a real number. And then we should be able to use that to get the answer we want. So let's look at how that works. So if we times these two fractions together, so this, remember, is the complex conjugate of the denominator, as I just said. So we want to be aware of that because it's going to be useful. So when we times these two things together, we get a plus bi over c minus di. That's just the numerators times together, and then we times the denominators together, and we get c plus di times c minus di. Now let's work out what these brackets are. So the first one on the top is ac, so that's the a times the c, minus a di, so that's a times minus di, plus bci, so that's the bi times the c, and then finally plus bd. So we get bi times minus di, b times minus d is minus bd, but then the I squared gives us minus 1, so we get plus bd. What do we get on the bottom? We just get c squared plus d squared, because we already said at the top that we're timesing the denominator by its complex conjugate, so we're just going to get the square of the real part plus the square of the imaginary part. So we already know that's what that is. We don't need to do it again. So now let's tidy up the top of this fraction. So we'll put the real parts together and the complex parts, the imaginary parts together, sorry. We get AC plus BD, they're the two real parts, so they don't have an I in them, those two terms. And then what two terms are remaining? Well, we've got the minus ADI and the plus BCI. So we put those together, we get BC minus AD all times by I, because I just factor out the I. So BCI minus ADI, factor out the I, and this is what you get. And then that is still over c squared plus d squared. So the point is now we have a complex number in the form that we want it in on the top. So it's a real part plus an imaginary part. And then we divide the whole thing by a real number. But when we do that, we can do exactly what we do with real numbers. When we have two things added together, divided by something, we can split it up into two different fractions. So what do we get? We get AC plus BD over c squared plus d squared plus BC minus AD over c squared plus d squared times by I. So I've split the single fraction into two different fractions. I've taken the real part over the denominator plus then the imaginary part over the denominator. And in the imaginary part, I've just put the I at the front. You can think about BC minus AD over c squared plus d squared I is the same as BC minus AD times I over c squared plus d squared. So I've just written it slightly differently. So what's my point here? Well, my point is that since A, B, C, and D are all real numbers, if we knew them, if we actually had two complex numbers, so we knew what A, B, C, and D were, and we plugged them into this, we would just get something in the form F plus GI. So this first big scary looking thing is F. It looks complicated, but if we plugged in numbers, it would just become some real number. And the second thing is G. So let's take an example. So write the following in the form A plus BI. 4 plus 3i divided by 2 minus 2i. So we're doing a division, but it's written as a fraction, and we want to write it as just some single complex number with a real part and an imaginary part. So what do? Well, we multiply by the complex conjugate of the bottom. Now the bottom is 2 minus 2i. Remember, the conjugate is where we change the sign of the imaginary part, so minus 2 becomes plus 2. So if it's a plus, we change it to a minus. When it's already a minus, we change it to a plus. Now we times out these brackets, and what do we get? Well, we know on the bottom, we said it's just the real part squared plus the imaginary part squared. We already said that, so we know it's just 2 squared plus 2 squared, which is 4 plus 4. And on the top, I've just times out the brackets, as I've been doing. 4 times 2 is 8. 4 times 2i is 8i. 3i times 2 is 6i, and 3i times 2i, well, 3 times 2 is 6, but then the I squared gives us a minus 1, so we get minus 6. So then I just tidy this up by adding the 8 to the minus 6 on the top, that's the real part, and I get 2, and then 8i plus 6i is 14i, so that's the imaginary part, and then 4 plus 4 is 8. So I get 2 plus 14i over 8. Now I'll break this into, well, firstly, actually I'll simplify it. So we can see that in the top and in the bottom, we have a factor of 2. So we can factor out 2 from 2 plus 14i. If we divide both of these by 2, we get 1 plus 7i. So we just divide the 2 and the 14 by 2. And on the bottom, 8 divided by 2 is 4. So this is just the same as simplifying a fraction when it's two real numbers. Like if we had 4 over 8, that's the same as 1 over 2. We just divide the top and bottom by 4. Well, it's the same thing here. We divide the top and bottom by 2, and we get 1 plus 7i over 4. So now we split this up. We get 1 over 4 plus 7i over 4, or 7 over 4i. So we have found the real part and the imaginary part. So this is just an example of how to divide one complex number by another. You just need to remember to take the complex conjugate of the second complex number, so the number on the bottom, when you write them as a fraction, times top and bottom by that conjugate, and then work everything out, and you'll get something in the form a plus bi, which is often what you'll be asked for when doing division with complex numbers.